Alright, this question is quite simply integration of rational functions by partial fractions. It may not be clear just yet, but let's make a small change. I'm going to write the denominator after factoring some stuff out. I'm going to take a common factor of 1 plus x squared times 1 plus x, simplify it by one more step, and I get 1 plus x times 1 plus x squared. Alright, now this is in the textbook case number 3, where qx contains at least one irreducible quadratic factor. So let's see how we fix this. We assume that the separated form, the separated partial fractions, have the form a over 1 plus x. The linear terms will always just have a constant on top, plus the quadratic functions, if they are not repeated, will have a linear function as numerator. Now, by the method that we use, by using partial fractions, what we are assuming is that this entire term combines to give this term here. As a result, what we have to do now is to equate the two. So a divided by 1 plus x plus bx plus c over 1 plus x squared is going to be equal to 1 divided by 1 plus x times 1 plus x squared. The only way to find out what a, b, and c are is to combine the two and try and express it in the form of the right-hand side. Alright, so we have a plus ax squared plus bx plus bx squared plus cx divided by 1 plus x times 1 plus x squared is equal to 1 divided by the same denominator. Essentially what we're saying is the numerator here, all this is just equal to 1. Okay, what does that mean? Well, that means that these terms, the x squared terms and the x terms, have to add up to 0, because there's no x squared or x terms on the right. So essentially, a plus b must be equal to 0. From the x terms, we know that b plus c should be equal to 0. And finally, we know that a plus c, because they are just constants, these are the terms that need to add up to 1. What do we get from this? From this we can get that a is equal to negative b. From this we get c is equal to negative b. But doesn't that mean that a is equal to c? Okay. Let's plug this finding into the last equation here. In that case, we get a plus a is equal to 1. And that's going to give me that a is equal to a half. C will also be equal to a half, and b will be negative a half. Fine. Now we can plug this back into our equation, our expression over here, and we get half times 1 plus x plus negative, I'm going to just put the 2 in the denominator because both b is a half and c is a half as well. So negative a half x plus a half For those of you who didn't understand it just yet, I just took the denominator 2 because this would be a half, this would be a half. Instead of writing 2 halves, I just put it straight away in the denominator. Right, so let's make this a bit simpler and see what it looks like. What I'm going to do first is take out the common factor of a half. What's left inside is going to be 1 divided by 1 plus x plus, I'm going to switch these two around just for convenience, so I can write it as 1 minus x divided by 1 plus x squared. For those of you who are looking for the 2, remember I took out a common factor of a half from both the first term and from the last term. So that half is over here. Okay, what happens next? I keep my half as it is. I'm going to break this term up so that I now have 3 terms and 3 integrals. Remember, I can break these up because there's only a plus addition sign in between. And the last term is going to be x over 1 plus x squared dx. Okay, these are pretty straightforward integrations, right? So the first term integrates to give natural log of 1 plus x. The second term integrates to give the arctan, or the inverse tan, of x. And the last term integrates to give natural log 1 plus x squared. But I'll leave this integration as an exercise for you guys to do on your own. You can just follow the lecture video on integration by substitution. Right, now, this isn't complete just yet. This term is not complete. What am I missing? Look at this. If I differentiate this, I'm going to get 1 over 1 plus x squared times the derivative of the inside term, which is going to be 2x. But the term I have over here is just x. So I need an extra factor of a half out here so that this half counters the 2. As a result, this is my final term, and my limits are 0 and 1. Now, let's plug our limits in and find out what happens. When I plug in my limit of 1, the first term becomes the natural log of 2, second term becomes the inverse tangent of 1, and the last term becomes half natural log of 2. When I plug in 0 here, this becomes natural log of 1, which is 0. Inverse tangent of 0 is 0, and half natural log of 1 is also 0. As a result, if we add this up, we get half times half natural log of 2 plus inverse tangent of 1. What is the inverse tangent of 1? It's just pi over 4. Now, I want to express this in the form that the answers are written. And so, what I need to do is I need to factor out a common factor of 4 from the denominator. What this is going to do is make the whole expression look like this. We had a half. I'm factoring out 1 over 4. So here, I'm going to be left with 2 times natural log of 2 plus pi. But we can simplify this term. If you remember your rules of logs, this simplifies to natural log of 2 to the power 2 plus pi, or in other words, natural log of 4 plus pi. Okay, let's go back to our answer. 1 over 8 plus natural log of 4, meaning the answer is